Today's episode is sponsored by CyManII, the Cybersecurity Manufacturing Innovation Institute. Visit them at CyManII.org.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. Now make sure to like and subscribe to get new episodes delivered to your feed each week. I'm Amy Bryson, contributing lead editor of Smart Manufacturing magazine, and today we'll be talking about the state of cybersecurity in advanced manufacturing, and that is certainly a big topic. And my guest is Gabriela Ciocarlie, Acting Chief Technology Officer for CyManII. And Gabriela is also an associate professor in the Department of Electrical and Computer Engineering at the University of Texas at San Antonio. And her experience is in anomaly detection, network and application level security, as well as cyber physical system security. So we have an expert among us who can help us navigate this complex landscape that is cybersecurity. Thank you, Gabriela, for joining us, and welcome to the show.
Thank you, Amy. I'm very glad to be here today.
Wonderful. Now, before we jump into our discussion, can you give our listeners just a bit of background about you and your role and exactly what CyManII does?
Sure. So my name is Gabriela Ciocarlie. I joined CyManII from the beginning when we were writing the proposal, actually. And my background is, I did my undergrad. I should say that I did my undergrad in computer engineering, so doing control systems as well. And then I did my PhD working on anomaly detection systems and cybersecurity. And then for the past years, I've been combining those two worlds, and I've been working and focusing a lot on cyber physical systems, starting with IoT, power systems, and manufacturing for the past more than 5 years now. So at CyManII, we've been working on a lot of wonderful topics. I've had the pleasure to work with the technical team, with the partners in education on the university side, with partners in the industry, and also with partners in the national labs. And CyManII is an institute, right, funded by DOE, but it also has this mission of building research for the future manufacturing systems, but also looking at ways in which we can help manufacturing systems of today. So we have a double mission there. One other thing that I would like to highlight is that we also have an angle on education itself. So there is a team that works on educating both students, but also the workforce. So that's another angle that CyManII is focusing on, and to be supported both in education and in our research. We have a team that does secure research infrastructure, where we have access to a lot of manufacturing system. That's where we perform our experiments and so forth. And then we have our partners in the industry where we test things in the real world.
So if you had to say, at the high level, why is cybersecurity for manufacturing systems so important?
Well, I think that it's very interesting. When we think about manufacturing, we most of the time think about physical artifacts, right? The result of a manufacturing process, it's some sort of a physical artifact. And a lot of times we don't think about security immediately, right? Security doesn't come to mind immediately. But there are many ways in which manufacturing systems can be influenced and attacked. And that final product that we see in the physical world can be manipulated along the life cycle of a manufacturing process. So there are ways in which attackers can alter the integrity of the part. So think about the design of a particular physical artifact, right? A part. an attacker can start right there at the design level and change something so small that can have a much larger impact once the part is in the physical encapsulation, right? And once the part is manufactured. So an attacker can start from the design, but the attacker doesn't stop there. Can continue to target the manufacturing process, can continue to target also the packaging of a final manufacturing result, right? Where different components are put together. So there are so many ways in which via the cyber link, an attacker can influence the ultimate integrity of a part. That's one way of thinking of attacks. Another way is to think of attackers trying to attack the actual machines, right? With the intent of harming people, or with the intent of compromising the physical spaces in which the machines operate. This was right. If you think about Stuxnet, right? The Stuxnet compromised PLCs, and then it caused fast spinning centrifuge, and then those were tear themselves apart. So that kind of a physical impact can also be seen as a potential risk in manufacturing systems, right? You want to destroy a full plant. There are ways in which attackers can try to explore. And then the last part that is very relevant as well is stealing IP information, right? Manufacturing systems for vital industries such as microelectronics also have behind a lot of IP and a lot of information that they don't want to share in general. So again, attackers can also compromise that. But there are so many other activities in which attackers can infiltrate. For example, if we think about the SolarWinds attack that happened back in December 2020. The attack targeted the supply chain of software, right? And there was a malicious code that was implanted in a legitimately looking update, right? The update was pushed in a legitimate way, but in reality, the code was compromised. So while all of that happened only on the software side, the equivalent can happen in manufacturing systems. Again, in manufacturing systems, we have this dependency between the cyber world and the physical world. So the supply chain attacks on the supply chains are very, very important, and we have to have protection mechanism against them because attackers can introduce different attacks at different stages of the supply chain. And those little manipulations can have a cumulative effect and produce a much more significant impact. One other, and I will finish with that. One other aspect that we also want to consider is that, okay, you can attack the supply chain, but you can also, by not having a way of protecting the full supply chain, and by not have a way of tracking what's happening in the supply chain, there is also the possibility of introducing fakes, right? And that we showed, unfortunately, the real world showed us that that's possible. It happened for multiple airline companies where they discovered that suddenly they had fakes in their airplanes. And that was due to the fact that there was no way, no proper way, let's say. I'm sure there is a way, but no proper way to track what is happening in the supply chain and how parts are introduced in the full pipeline of replacing parts. So these are kind of the types of challenges that manufacturing systems face at the moment.
Yeah. So given all of that, I mean, what you described, those are a lot of challenges, and it can feel overwhelming to start to, tackle those. So how does CyManII approach securing manufacturing systems? What are some of the key technologies that you're developing? Can you talk us through some of that?
So CyManII is taking a global view of manufacturing systems. We have a unified vision for both automation. Automation, think about a factory, right? Think about one node in the supply chain, but also apply the same kind of concept across the same unified approach across the supply chain. And we also distinguish between different capabilities that we are exploring that are providing prevention versus mitigation, right? Prevention means that you have capabilities where you have a secure by design approach. So then a secure by design approach will prevent certain classes of attacks. Mitigation works more on the other side, where you have a way of detecting and assessing that something is happening in the system, and then you have a way of providing resilience capabilities. So we are looking at both aspects, and we created what we call a secured defensible architecture that operates across the full life cycle of a manufacturing system and across the supply chains. And along the lines, we have different capabilities. And I'm going to focus, for example, on this concept of cyber physical passports. So I've been talking earlier about having a way of collecting provenance and having a way of tracing what's happening, and also having a way of verifying what is happening across the manufacturing system. So this is what the cyber physical systems really provide, these capabilities of verifying the process and also tracking everything. So imagine that you have your own passport, right? You have your own passport, you have an identity, and your passport is tracking all the different traveling capabilities, right? All the different travels that you take. It's exactly the same concept for the cyber physical passport, but this time we are talking about physical artifacts, right? And we are building passports from the design of a part to the actual manufacturing. And then when we talk about supply chain, we combine all the information across the supply chain. And along the lines, every kind of verification that is done at all these different stages is also captured in the passport. The idea is that you don't have only transparency and the full provenance of what happens in the manufacturing process, but you also have the ability to prove certain characteristics. So you can prove that certain verifications have been done along the lines of the supply chain, and then you have the ability to say to offer some guarantees for those parts. We capture all this information also to offer productivity improvements, right? If you have a good view of what's happening in a supply chain, you also have the benefit of improving the productivity. You can see what supply chain nodes require better improvement, where you are missing information, where things can be done better. And of course, in terms of security, right, with all these different verifications on all the stages, we have the ability to observe any type of attacks, and we also have the ability to share information across the supply chain to protect them. So that's one of the technologies. So imagine at the end of the day, every product that has a particular criticality can have this passport, and then with that passport come all the different assurances that have been provided along the way. But then when we were building these cyber physical passports that also include software, S-bombs, H-bombs, they include information on the design, they include all the software that was needed in the process of manufacturing. We realized that now we have something that is beyond an S-bomb. We have something that we call software trail of manufacturer part. And now we are linking software components via not only cyber links but also the physical links. So we have a way of saying, hey, this is what the software trail for a manufacturing part looks like, and these are the potential points of attack, and this is how you can protect the system better in terms of software only. So these are two of the capabilities, and I've been talking about the prevention part, right? We also work on formal verification, so having the ability to build systems for which you can say at the design level, these are the guarantees of these systems, these are the different properties that we want to have. And those properties can include, because we are in a cyber physical system, can include both safety and security guarantees. So we have one framework where we can analyze both safety and security. And we are building this framework called CADA and compositional attack defense architecture. So here we have the ability to say about an architecture of a manufacturing system. We have the ability to do an analysis even before you put the system together. You can apply the same technique for existing systems, but this is how you can start building the future manufacturing systems, where you can design, build your architecture, analyze it, do a penetration testing on an architecture, on the model of that system. So that gives us the ability to prevent potential attacks, because we look at guarantees with respect to certain classes of attacks. So these are some of the ideas that we've been focusing on, and we are also looking at other things such as firmware. Right, firmware is the most difficult component of a system to analyze. Why? Because the firmware is very closely linked to the actual devices. So most of the time, if you want to analyze firmware, if you are on the device, you can actually damage the device. So we have techniques in which we are lifting the firmware from the device. We can analyze it in on a regular system, so detaching it from the cyber physical system itself, but still have the emulation of that system and having the ability to analyze the firmware, to do fuzzing of that firmware, so that we have the ability to identify potential issues and also come up with ways in which they can be fixed. So everything that we are doing is building tools that support small manufacturers and larger OEMs, and we want to have we have this SDA, we have this architecture, but it's not only an architecture on paper. So everything that we are building has the equivalent of a reference implementation. We want to make sure that that comes together with a concept, so that it's easy for everyone to adopt and use in our institute, but also beyond the institute.
Mm-hmm. I'm glad you brought up the point about working with small and large and OEM manufacturers, because in some of the conversations I've had over even the past couple of years, there seems to be a misconception that smaller manufacturers are somehow immune or not as desirable from a cyber attack perspective. What is your perspective around the importance of manufacturers, even the smaller manufacturers, to take a proactive stance as it relates to cyber preparedness?
Yeah, I think everyone is at risk, small or large manufacturers, it doesn't matter. Sometimes, the small manufacturers are in that supply chain that I was talking about. So having they can be a target just because of their existence in this whole in this bigger picture. And if you target a particular smaller manufacturer, you end up with a result at the larger scale. So, but I think that everyone at the moment is all the manufacturers are driven by digitization, right? Everyone wants this digitization, and with this digitization comes of course, the digitization offers increase in productivity, but on the other hand, there is an increased risk of cyber attacks. So there is this balance of, okay, we have digitization and we have potential attacks. And again, small or large, everyone has the same risk in a way. And we noticed that there is an increased trend in attacking systems in general. A lot of times attackers enter the IT side, and then from the IT side, they cross the bridge towards the OT side, and then they can have an impact in the actual manufacturing systems. We noticed a lot of ransomware, right? There are a lot of news about ransomware being the preferred engagement by the attackers. But those are not the only vehicles. Like I was saying, there are ways in which you can reach the OT systems from outside, and then there are other potential damages that can be employed. So we have, everyone is at risk, and the way we say inside CyManII, we have this secure together. There is no way of everyone to really go against the attackers unless they work together, right? So when we talk about these technologies that we are developing, like the cyber physical passports, are going to have a significant impact when they are leveraged across larger industries, so that everyone can benefit from them and everyone can be protected together.
Yeah. And, earlier you mentioned the education piece, which is so important because, training staff and frontline workers on, things to look for or even certain behaviors to not adopt or to adopt as it relates to mitigating risks is so important. And so talk me through a little bit about how, you and your team and this kind of working together notion is making cybersecurity technology easier to adopt by manufacturers and their supply chains.
Yes. So one thing I want to iterate the fact that we are a research institute, so we are now developing new technology, and but we want to push our technology out as soon as possible, right? So one step that we've been taking, we have these industrial use cases. So these are projects that are running at the moment. There are 10 of them running at the moment, where we are working very close with the industry. So there is no way in which any technology will be adopted if it's just built in the lab, right? They working side by side with the industry and really noticing and paying attention to their needs and seeing how and where things can be best deployed is the way forward. So we have these IOC projects where we are creating pretty much pilots, right? We make awareness and we show the benefits of our technologies to our industry partners. And we work closely together, like literally closely together, meeting every week and talking about ways in which we can push the technology together. So one other thing that can take us to the next level is this idea of an open architecture, right? So we create this, let's take the CPP technology. This is an open architecture and we want to enable easy access to it and ways in which it can be adopted. So I mentioned the reference implementations. Those are a way of taking us to the next level of producing a standard in the industry and even going to the level of standardization, right? The real standardization. So we want to have these building blocks for building secure systems and offer tools that can help manufacturers and empower both small manufacturers and, of course, working with the large manufacturers. Cybersecurity is a teamwork. right? Our logo says, secure together, and that's for a reason. I mean, nobody can do things by themselves, especially when we talk about small manufacturers, right? So manufacturing means supply chains and having the ability to provide guarantees for quality, but implicitly you also need the guarantees for cybersecurity. So that you stay competitive. Any type of attack can put a small business out of business at the end of the day.
It's extremely important. I mean, when you look at the future of manufacturing, what are some things that keep you up at night? But also, what are you excited about in terms of the opportunities to help the manufacturing industry become more resilient?
So if I'm thinking on a longer time frame, let's say, I hope we get to the day when we can build the manufacturing systems based on building blocks that provide both safety and security guarantees. So imagine like a Lego, right? The same kind of concept of a Lego. Now you have tools and you have components and you have machines that have been verified already using our techniques, for example, for formal verification, right? Those have been already verified. So when you want to create your new manufacturing plant, you already have the ability to look at a component and a machine which has software that has been formally verified, which has these particular guarantees, and then you put it together with another system, and then all these systems, when are glued together, they have the security and safety guarantees, but they also come with the benefit of offering a transparent way of collecting provenance and generating the passports at the end, and you have a full traceability of what's happening in the manufacturing process, and you have the ability to prove those guarantees to your customers. So I'm thinking that would be a nice future that we can have, and also think about autonomous manufacturing, right? We talk about systems that are autonomous, but what about manufacturing plants that can be easily repurposed? So that's another thing where I'm hoping that we are going to see more traction in the next years. How do you easily take one manufacturing plant and then reshuffle it so that it creates a different pipeline? So having these autonomous capabilities where you have robots that enable that pipelining of an automation system. Those are the kind of things that I hope we can find. And all of that with cybersecurity as a given. So cybersecurity as the foundation for such systems.
And if a manufacturer, could take one action today related to their cybersecurity preparedness, what would you recommend that be?
So having visibility in their systems is the first time. Yes, training, of course, that's the first thing, but also having visibility of systems. A lot of times, knowing what are your potential attack entry points is actually very valuable, because then you can start to build from there ways and applying different techniques that can protect you. So knowing their systems better, having a way of accessing and a view of their systems, I think that's the first step.
And if our listeners want to learn more and follow up on some of the things that you talked about today, where should they go?
So they can go on our website on www.CyManII.org. We have some of our projects mentioned there. We also have some of our publications, and we will make sure that all of them will be there. Some are missing, so we will upload those as well. But we have our publications there. We tend to work both with the academia world and the industry world, and you will see publications that are on both sides. And we participate in a lot of the conferences and events in our world, and you can also visit us at our booths and meet us at all these events. But start from the website, and we would love to hear more from our listeners.
Wonderful. Yeah, there's a lot of great resources and information for listeners. And I know most of our listeners know this, but if you don't, CyManII is CyManII. Make sure you look them up. And Gabriela, I want to thank you so much for taking time to join us and sharing your insights with our listeners. And I also want to thank our listeners for tuning in. Don't forget to like and subscribe to our podcast feed and stay up to date about what's happening in advanced manufacturing. Also, you'll find a host of resources by visiting us at advancedmanufacturing.org. Take care, everybody.